Hey guys, welcome back. So the agenda of today's session is to understanding about the basic concept of error detection techniques, right? So we have the different types of error detection techniques. One is called as the vertical redundancy checker. The second one is longitudinal redundancy checker. Then one more is the checksum method, CRC method. So all these four methods can be used to perform the error detection operation. The error detection means to know whether the received information is error or error free. That is what we called as the error detection, right? So first we'll see about the single parity check or VRC method, then two-dimensional parity check or LRC method. So as part of our syllabus we have only checksum method as well as the CRC method right? So most probably we are using either checksum method or cyclic redundancy checker method. So what is the meaning of single parity checker VRC method? Suppose for example, as I have explained in the previous class, if you are sending the so if you are sending the data or message bit alone from the transmitter to the receiver through the channel, if you receive something, this information or some information, we cannot able to find out whether the received information is correct or not. Means we don't know what is the information which is sent by the transmitter, but some information will be received at the receiver. So the moment you receive this information, we need to identify whether it is error or error free, right? So see that here at this point of time, without knowing the transmitter, you cannot find out, right? So for that we require something called as the redundant bit or extra bit values, right? So for single parity check, we are going to use some extra bits, or that extra bit we called as the redundant bit. So what is the use of this redundant bit means? So along with this message bit, the extra bit will be added. With the extra bit, we are going to send the information from the transmitter to the receiver. So with the help of this extra bit, we are going to identify whether it is correct or not. Now this is my information. So for that, using the even parity method, if we count the total number of ones are 1, 2, 3, 4, 5. 5 is odd number, right? In order to make even, we are adding plus 1, right? So this is the even parity. Now see, along with our message bit, we have the extra bit. We are transmitting through the medium, then we are receiving. So here again we have the checking function. What the checking function do is, it will check whether the receiver code word is in terms of the even parity or not. See that 1, 2, 3, 4, 5, 6. If 6 is there, it is even parity mechanism, right? So that it will accept the data. Other than even parity, if it detects odd parity mechanism, something like this. Now total number of ones are odd, so it will reject the data. Reject means it will ask the sender to retransmit the same data one more time. The same method adding extra bit, either it may be VRC or it may be LRC or it may be checksum or CRC method, we are using the same redundancy concept. Right? Now what is the drawback of the single parity check? See that this is the transmitter information, this is my received information. So which parity method we are using? Suppose for example, let us say we are using the even parity method. So total number of ones are 1. So I am adding the extra one more bit, nothing but the even parity mechanism. So this is what we called as the message bit value. This is what we called as the this one we called as the parity bit or extra bit or redundant bit value. So after sending the information from the transmitter to the receiver, now how many bits it is changed? 2 bits it is changed, right? For example, see, from transmitter to the receiver, 2 bits were changed. Now which method we are using? Even parity method. As per the even parity method, it is wrong or right? Just check it. See that. Count the total number of ones here. 1, 2, 3, 4. 4 means odd number or even number? Even number. So as per the even parity mechanism, the receiver also we have the 4 bit which is the even, it is correct, right? As per even parity mechanism. But the moment if you understand here what is happening, the information is different, the receiver is different. But what is the limitation of single parity check means, if only one bit changes from the transmitter to receiver, right? If only one bit changes from the transmitter to the receiver, then this single parity checker will helpful. But if more than one bit changes like this, what is happening? So even though as per the even parity we are telling it is correct, but actually it is the wrong information. That is the limitation of the single parity check method. So for that we are going for the something called as the LRC, right? So see that it only detects the single bit error which are very rare, right? If two bits are interchanged, then it cannot detect the error. That is the limitation of the single parity check or VRC method. Now see that suppose if you want to send the block of the data codes, suppose this is one, this is another code, this is another code, this is another code, right? So for this also in earlier case we have sent only one data, but here we have the data blocks, right? What is the first data block? 1110011, right? Just I'm going to write here. Again, what is the next data block? This is the data block. What is the next data block? This is the next data. This is next data. Now here for example, suppose either you can perform the even parity or odd parity. Let it be even parity method. Even parity means total number of 1 should be even, right? If total number of 1 should be even, then we need to add the extra bit is the 0. If it is odd, we need to add the extra bit equal to 1, right? So in this direction you count 1 1 1, right? So see here, this is the value 111, right? So 111 means it is the even number or odd number? Odd number. If you want to make the even number, what should be the answer? The answer should be 0, right? So here I am writing the 0. Now see that 1100, even number, right? So answer is, sorry, here what is the answer we should add? Odd number means 1. So this is even number means 0. This is odd number, 3 ones means 1. So if you add 1 means then it will become 4 number. So it will become the even parity. That is the meaning of that one. Here it is 0. Here it is 1. So I have done mistake. Sorry guys. Here 3 ones, right? 3 ones means yes. Here it is 1. 1 1 means here it is 0. Here 1 1 means, so 111 means 1. So 11 means 0. Again 111 means 1. Okay, correct only, no problem. Again 1 1 means here the value is 0. Again single 1 means again 1. 4 ones means 0. This is what we called as the two-dimensional parity checker or long parity checker. See that the same thing here I have written, right? So 111 means 1, 11 means 0. Odd number means 1, even number means we need to add the 0, right? So this is the example. So now see that, so this is the data blocks, right? So this is the LRC we have find out by using of the even parity method. Now what we have to do means we have the extra bit mechanism, right? This is nothing but our extra bit value or what? Redundant bit value. See, so along with this is nothing but this one, this block is nothing but this one, this is this one, this is this one. So for these 4 blocks we have added the extra bit or redundant bit. This is the 5th block. Now this information will be sent along with your data. We are going to send the LRC mechanism. At the receiver side we are going to identify whether it is error or not based on this LRC method, right? So but actual method we need to find out the based on the checksum method as well as the CRC method. So LRC, VRC, so this is only for just example only. So most probably we will be not getting in the exam point of view, right? So those are the basics to understand the checksum method as well as the CRC method. So in the next class we will try to solve the problems based on the checksum method and CRC method. Thank you guys.